Hello everyone, let's solve remaining 3 questions of Jest 2021. Okay, let's start. A circular ring of radius r with total charge q has uniform linear charge density. It rotates about an axis passing through its center and perpendicular to its plane with a constant angular speed omega. Okay, let's draw a ring that is rotating with speed omega and that of radius r and bearing a charge of q, suppose qr, and then the magnetic field at the center is found to be b naught. Okay, magnetic field b naught. Then another thin circular disc of the same radius r has a constant surface charge density with a total charge q disc. Okay, this disc too rotates about the same axis as the ring with the same constant angular speed omega. Okay, this is disc. It is also rotating with omega and having radius r. And then the magnetic field at the center in this case is, suppose that is B2 is equal to 10 to the power minus 3 B naught. It is given. Then what is the ratio of Q ring by Q disc? Okay. We have to calculate this. So this is ring and this is disc. Okay. As you know, a rotating ring carrying magnetic field B, from the basics, as you know, magnetic field due to ring will be mu naught I by 2r. Okay. And here charge density is a constant, so I is equal to q by t and t equal to 2 pi by omega, so omega q r divided by 2 pi. So this here mu naught I omega q r divided by 2r into 2 pi, so mu naught omega qr divided by 4 pi r. This is equation 1. Here we get magnetic field of ring with relation qr. Then let's go to the disc. Okay, here disc. So this disc is continuously charge distribution. Continuous object, so charge distribution is different at different points, and this is rotating. So let's take an element at a distance r. This is r and dr element, so this is dr. So magnetic field due to this element is equal to dp is equal to mu naught di divided by 2r, and di is equal to dq by t, and dq will be dq, okay, 2 omega by 2 pi dq and this will be the thing. As you know, here dq is equal to sigma dot dA, so omega by 2 pi sigma is equal to q disc divided by pi r square into 2 pi f, let me take here 2 pi r dr, that is the dA. Okay, then put here all this mu naught by 2 r into omega by 2 pi into qt divided by pi r square into 2 pi, sorry, this magnetic field here, so radius will be r, this is r, 2 pi r dr, so 2 pi cancel, and okay, mu naught omega by pi r square qd integration r cancel, so this will be r from 0 to r, so this will be mu naught omega qd by, and remaining 2 here, so this will be 2 pi r. Okay, this is equation 2. So this will be, this will get ed due to disk, so divide equation 1 by equation 2, then we get br by bd is equal to qr by 2 into 1 by qd, that implies qr by qd is equal to 2 into br by bd, then 2 into b naught divided by 10 to the minus 3 b naught, so 2000 is the answer. Okay, let's go to the next question. Okay, it is given here. Consider a sphere of radius r. Okay, sphere of radius r with volume charge density rho. The charge is 0 outside the sphere. Okay, the electromagnetic potential phi and a inside the sphere may be written in many ways. Okay, which of the following will be the value of phi and a inside the sphere? Describe the situation correctly. Okay, as you know, in case electromagnetic waves, our electric field contains both phi and a, like this. Where phi is the vector potential, sorry, scalar potential, a is the vector potential. Okay, this due to accelerated charge. Okay, then in case Gauss transformation, from Gauss transformation, as you know, change in phi prime is equal to phi minus del psi by del t, and a prime changes is equal to a plus grad psi. This should obey in any vector or scalar potential. Okay, then here charge density is given, so we can calculate electric field. So as you know from Gauss law, electric field inside at inside point at a distance r is equal to 3 dot 4 pi r square integration of rho dv by epsilon naught, and here rho is given, that rho is 4 pi epsilon naught, 4 pi epsilon naught and divided by r, and that volume element is equal to 4 pi r square dr. So r cancel, and here 4 pi cancel. That implies electric field is equal to 1 by r square, and integration is inside the sphere, so 0 to r, and 4 pi take common, 4 pi alpha also, epsilon cancel, and remain r dr, 4 pi alpha by r square by 2. So this is 2 pi alpha r. This is the expression of electric field. So we get electric field is equal to 2 pi alpha r and r cap. So this is the electric field. So we have to calculate the form of phi and a, so that this electric field should obey this. Okay. From option A, if phi 0 and a is equal to minus 2 pi alpha t r cap, minus 2 pi alpha t r cap, then electric field is equal to 2 pi alpha and sorry, no r here, r cancel. It is 2 pi alpha r cap. This should obey. So option A is correct. But if you calculate phi first by using Poisson bracket equation, I am saying another also. If you calculate first minus rho by epsilon v, then we will not get the similar expression of E, electric field, as we get. So option B can be the answer. So option A will be the answer. Okay, let's go to the next question. As you know, this question already has come in exam several times, so it will be very easy for you. Still, I am going to solve this again. Okay, an ideal polarizer is placed in between two crossed polarizers. Okay, in a coaxial geometry as shown in the figure. The middle polarizer is rotated at the angular speed omega about the common axis. Okay, if the unpolarized light of intensity I0 is incident on this system, the emergent intensity of the light would be. Okay, suppose this is unpolarized light. Unpolarized means it contains electric field in any direction, not a particular direction. But if we use polarizer, that the direction of electric field get fixed in a particular direction. Okay, and this is the transmission axis. Unpolarized light coming through this fast polarizer, it gets polarized, and that's average intensity will be I naught by 2. After passing through this, and this is rotated by an angular transmission axis, come to this is T1, come to here T2 by rotating omega t. Okay, angle omega t. So this is I1 and I2 will be by using Malus law. A equal to I naught cos square theta. I1 is equal to I2 equal to I1 cos square omega t, and that is I naught by 2 cos square omega t. And then again the transmission axis get horizontal with this. Okay, so we have to find the angle between the previous transmission axis with the present transmission axis. That will be the angle. Okay, if this is the present transmission axis, then previous transmission axis is this one, and this given omega t, and this angle is not given, so we can know that is 90 minus omega t. So I3 will be I2 cos square 90 minus omega t, that is I2 sin square omega t. So put I2 equal to I2 by 2, I naught by 2 cos square omega t sin square omega t, and I naught by 2 into 4 into 2 square this, so I naught by 8 sin square omega sin square 2 omega t. But our answer is not in this format, so we have to change this. I naught by 8 sin square is equal to 1 minus cos 2 into 2 omega t divided by 2. So I naught by 16 1 minus cos 4 omega t. This is the answer, and here is the option B is the answer, right answer. So all the 3 questions are finished. So thank you, and keep watching. Please keep watching and subscribe and share. Thank you.